Okay, so it sounds like last week went pretty well practicing all these functions and stuff. Did we feel stronger with some of those things? I wasn't sure the quality of the internet connection I was going to have, so I had Ben, uh, I don't know, do whatever. Did he do a decent job, or was
He
he
did terrible.
was he bad? Sometimes, sometimes it kind of goes that way with him. It's not a compliment. All
Did
right.
not seem happy to be.
Huh?
He did not seem happy to be
Oh,
here.
really? Oh no, he definitely he loves when he gets responsibility.
It's just personality. You gotta get.
Oh yeah, yeah. His it's not a good personality, he has a bad personality. But he is actually a nice guy, just a little rough around the edges. All right. So let's pick up where we left off. We were talking about fractions, but really we were just using fractions as an example of data representation. So let me get a slide going on here. Oh, just so let's finish covering this thing here real quick. I kind of left it hanging at the end of class, this bitwise thing I mentioned. Um, so if you did I have an example in here down in Maine? Yeah, so right down here, if I print 26 with an ampersand 13 and I run that, we see that we get an actual value of an 8. 26 and 13 gives us an 8. Like, why does that make any sense? So let's look at that here. Um, I did mention, and again, this kind of falls into that category of things that make me not a huge fan of Python. It deviates from kind of the C-based thing that we've had for so long. So in Python, at least in Python 3, I think Python 2 did allow the double ampersand and the double um, vertical bar. But uh, regardless, we're talking about the idea of Boolean expressions, being able to create Boolean expressions to allow us to ask questions that either control an if statement or control a loop or whatever. C, C++, Java, C Sharp, Objective-C, Swift, pretty much every language other than Python uses the double ampersand, this guy right here, this operator, no spaces, uses that to represent the I'm sorry, the and operator. Where in Python 3, which is what we use now, the whole reason you might see some differentiation online, like you might see Python 2.7 and then you see like Python 3.18 or something, I think is the newest, whatever it is. That's actually left over from like many years ago. Many years ago, let's call it like 10, might even been longer than that, but let's just call it a decade ago. A whole bunch of people had written their software in Python 2.7 or Python 2. And then they released Python 3, but it wasn't necessarily backwards compatible. So a whole bunch of people's software broke. So for a while there, they had both being maintained. So sometimes you'll see, like for instance, if you installed Python locally on your computer, the Python command might be Python 3 instead of just Python. Maybe on Windows, they've abstracted that out now, but really anymore, everything's Python 3, so we don't even need to reference it separately. Python is Python anymore, but if you ever see that, that's the situation. It just is still going to be stuck in a bunch of documentation. But in any case, most programming languages, when you say the and operator or the or operator, they use the double ampersand or the double vertical bar. But, oh, I got somebody to admit. So, for example, if I go in here and I say print 26 and 13 using the double ampersand there. I think this is going to give me an error. Then I'll switch it to and. Let's just confirm this for a second. Yeah, invalid syntax. So just bear with me and pretend that says double ampersand for a second. So when I run this, I get this value of 13. It's actually interesting. I wonder why I'm getting 13 for that. Well, let's see if we stumble into it from this other thing. That should have been a, this actually tells us something about how Python treats Booleans as either zeros or ones under the hood when we talked about the primitive types built into languages. And maybe I'll see if this is also doing a bitwise. That's something that could be happening is it sees that both of these are numbers and says, oh, you're using the word and, so we're going to do this as a bitwise operation, which I'll show you what that means here in a second. Typically, when we use the and keyword, we have a Boolean expression on one side, a Boolean expression on the other side, and is only true if they're both true, right? And an or is true if at least one of the two sides is true. And what's a Boolean expression again? Yeah, any expression that boils down to a single value of true or false. So let me actually just give you one more thing here. I'm going to show you. Yeah, I'm going to show you how bitwise works. I'm just getting a little bit more out here. I'm guessing this is not in Python either. They probably have another. Let me just test this here real quick. No, so must be doing a bitwise XOR. Okay. So this is what's called an exclusive OR. So these three Boolean operators, I'm going to say is typical in most programming languages. Python's doing some magic stuff behind the scenes that I'll talk about in a second. It seems clear what it's doing. But for an and to be true, both sides need to be true. For an or to be true, at least one of the two sides need to be true. For an exclusive or to be true, exactly one of the sides is true. So both of them being true. So true, exclusive, or true is a false statement. We'll actually see if it proves my, yeah. So it is doing that. True, exclusive, or false is true because exactly one side is true. But if I had switched that to an or, true is going to be true. Oh, or true is true. See, isn't that annoying that every single language uses double ampersand or the double vertical bars except Python? Killing me. So in any case, 99% of the time, when you are writing your programs, you will be exclusively using ands and ors for creating Boolean expressions. Once in a blue moon, you might find a situation where an exclusive or an XOR makes sense. Does anybody happen to know where when XORs might be more commonly used? And I'll throw out another word that might give you a hint towards this. Also, we have these things called NANDs. NAND is not and, the inverse of an and. So anybody know where exclusive ORs and NANDs are commonly used today? Building hardware. When you build your computers or any sort of electronics, you build things out of these things called gates. When you take computer organization next semester and you start working with physical Boolean logic, making circuits and stuff like that. We have AND gates and OR gates and XOR gates and NAND gates, NOR gates. We have all sorts of different gates. Now, when you do this on paper, you have like a symbol for these different gates, but these things physically exist in the real world. You know, you can mess with them like with Arduinos. If you go to any of the CS Club things that do Arduinos, I think they're going to probably have a thing where you're doing different wires and, you know, we don't do soldering them together. We use a programmable controller board called an Arduino in the middle, but then we connect stuff to it. But when you're building a circuit like that, you might use AND gates, OR gates, NAND gates, things like that. Well, because these companies that make electronics are operating off of zillions and zillions and zillions of parts, what they typically will do, most of these gates can be defined in terms of other gates. So usually they use XORs. Well, actually, usually anymore they use NAND gates, but they used to use XORs. And what they would do is they would use those two gates to simulate all the other gates. You know, you could create them in combination to simulate other gates. So what they would do is they would buy a bazillion NAND gates to keep the price down because the price per unit became lower if they were just buying tons and tons and tons of these. And then all of our electronics were prototyped using those. And then they do the large scale thing and print it on printed circuit boards and stuff. So you never actually see it. But that's where those things are commonly exist today. So realistically speaking, even though we do have a symbol in our programming languages for an exclusive OR, it's rarely used. Usually it's just ands and ors. But let's get to this 26 and 13 thing. Putting in the accidental typo in a typical programming language where I forgot to put the double ampersand and instead only put a single ampersand. And instead of it screaming at me, I get a number. In this case, I get the number 8. All right, so we're going to look at why we get an 8. All right, so for starters, let me add a slide here. So 26 and what was it, 13? 13, this guy equals 8. So the question is why? So the first thing we need to do is we need to get the binary version of 26 and 13. What's the binary equivalent of 26? Well, we'll have 1 in the 16th place, 1 in the 8th place. That gets me to a 24. 0 in the 4th place, because that would go too high. 1 in the 2's place, 0 in the 1's place. Once the numbers get too big, then that approach becomes scarier. Then you go and do the divide by 2 thing. All right. So that is 26 in binary. So this is the 1's place, the 2's place, the 4's place, the 8's place, the 16. So this is 16 plus 8 plus 2, which gives you 26. And what about 13? That's 1 in the 8's place, 1 in the 4's place, and 1 in the 1's place. So this is 8 plus 4 plus 1. Now what I'm going to do here is I'm going to throw an extra 0 in front of that. So both of these binary numbers are the same length, same number of bits. 0, 1, 1, 0, 1 is the same value as just 1, 1, 0, 1. That a 0 times the 30 seconds, or the 16th place in this case, will be 0, doesn't change the final value. All right, so now what happens is when I say bitwise and or a bitwise or, so let's just put that above it. Bitwise operations apply the operation to each individual bit of the binary representations of the values and then show the decimal version of the result. So if we go through here, remember we're dealing with an and in this case. So one and ands are true when both things are true, right? When they both have a value of 1, the resulting value would be 1. Well, it's all values. So the very first question we say is 1 and 0 is 1. Because both would need to be 1s in order for, I'm sorry, 1 and 0 is 0. Sorry. So 1 and 0 is 0. 1 and 1 is 1. Since both are true, the final result is true. 0 and 1 is 0. 1 and 0 is 0. 0 and 1 is 0. What number is this? This is the 1's place, the 2's place, the 4's place, the 8's place. That's the number 8. So that's a bitwise operation. Very, 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 very likely you will go through your entire software engineering career and never have to do bitwise operations. Okay, so don't try to squeeze this into your toolbox somewhere. I'm not going to test you over this. What I'm really why I'm telling you this is a simple typo gets you this answer that you wouldn't understand. Like, oh, I'm dealing with Booleans, yet I put numbers on either side and it didn't scream at me. Why? That's the weirdness that's going on here. If we were to do a bitwise OR, let's actually do it. Let's pretend this was an OR instead of an AND. So a bitwise OR, 1 or 0 is 1. 1 or 1 is 1. 0 or 1 is 1. 1 or 0 is 1. 0 or 1 is 1. What number is this guy? So this is 1s, 2s, 4s, 8s, 16. So 16 plus 8 is 24. Plus 4 is 28. Plus 2 is, am I doing it right? 16 plus 8 is 24. 28, 30, 31. Did I do that right? There's our 31. All right. So that's what's actually happening if you had a typo. I suppose you could say that Python 3 kind of fixes this problem by not allowing those typos, right? Because and or, but what we just saw here is if I do an or like that and run it, oh, that's actually interesting. 6 or 13. What operation is that actually doing? What I assume was going to happen here with Python is that it was treating, since I had numbers on both sides, it was treating the OR operator as a bitwise OR. Similar to what, like we've used the plus operator, you're doing string concatenation. So if you have strings on both sides, it does concatenation. If you have numbers on both sides, it does addition. Okay, so 26 or 13 gave me a 26, so it's picking this first number. Typically, this would be a 26. So the way Booleans are represented in older languages are with just integers or byte primitive types. So 0 is false. Anything not 0 is typically considered true, even though you usually think of a 1 as true. So this would be true or true, which should be true. I'm not sure why it's given a 26. That's just weird. I'll look into that. Kind of unimportant. It's not something you're ever going to need. The bitwise operations are also things that you will very likely never run into unless you get into making computer hardware or the computer engineering side of things. Never test you on it. This is just something that explains why if you get a weird number when you thought you were looking for trues and falses, that's what's going on. All right. So you will not be tested on this at all, but that's the dealio. All right. Questions about that before I go back to our fraction stuff? Okay, so pull this back to fractions. All right, so now let's think about it from a computer programmer perspective. We know we're going to be dealing with some fractions. We already wrote some code that added fractions together, right? We decide, okay, you got two fractions. How do you add fractions together? Well, we find a common denominator, blah, blah, blah. You add them together. You can also then go and reduce them if you want by finding the largest divisor of both of them. I think we did that last time. We're going to talk a little bit more about that today. But let's take a step back for a second and just think about the different ways we can solve this problem. All right. So in your mind right now, I want you to kind of go back to first week of class when we were talking about the object-oriented versus the procedural telephone. Remember that guy? Okay, where the procedural telephone looks like a giant pile of wires. Object-oriented telephone looks like a telephone. In real life, we like things that look like telephones. We think of things in terms of objects. All right. So understand that when we're going through the history of programming languages and we're trying to figure out how did we get to where we are today, this ultimately came down to how did human beings wield these languages? In the earlier days of computers, we didn't need as powerful of languages. Let's just use powerful abstractly there, because the problems we were actually solving were trivial problems compared to the problems we're solving today, right? Part of it was we didn't necessarily have the computing horsepower to solve really complex problems, either in processor speed, so yeah, way faster than humans, but not like crazy fast like we might think of them being today, and even crazier fast they'll be in the future. But we also had a limitation on memory. We talked about that with the Y2K bug and all that stuff. So, we were fairly limited on our hardware, which then meant the problems that we were going to try to solve as human beings using this tool, using a computer, were fairly limited. So any weaknesses with our early programming languages were not that bothersome because we weren't really running into them being inconvenient very often because the problems we were solving weren't that big. Make some sense? Also, you have to think about how human beings adapt to the stuff around us. We're all running around with smartphones today. A smartphone is a very different tool in our daily lives today than the day BlackBerries first came out, right? Because now we assume everybody has email in their pocket. Everybody has the web browser in their pocket, all this stuff. When the first actual usable web browser in your pocket came with the original iPhone. It was a usable web browser. Before that, the web was, hey, if I'm in a jam and I need to get the phone number for a place, I maybe sort of could get something out of a web search. So we've evolved to use these tools differently. Same thing's true here. As human beings started solving more and more and more problems with our computers, we came up with more innovative ways of using computers to solve the world's problems. Again, we now need a better weapon than some of these older languages. We need it to be more convenient, have better bells and whistles, just like we wanted the telephone to, first of all, not be attached to the wall so we could walk around the house with a wireless telephone. Then we said, well, I don't want to be attached to my house either. so now we put cellular radios in them and we can walk around the neighborhoods and blah, blah, blah. So this just kind of comes with the tool evolving. All right, so when we want to solve a relatively trivial problem like fractions, as a programmer, we get to choose how we want to represent that object, that thing. So this is talk about data representation. How do we represent the kind of data we are working with to conveniently transmit data between functions and programs? All right. So for example, if you are sending a birthday card to somebody, what format? So you go out and buy the card, hopefully you print them out now because you don't want to spend $11 for a birthday card, but whatever. Let's say you go out and buy the $11 birthday card, okay? And you're going to send this to your friend, your mom, whoever. How do you package that up to send it to them? What's the go-to method for representing, for transmitting a birthday card. Put it in an envelope, probably send it in the mail. I think I saw on Jimmy Kimmel or maybe it was Letterman years ago that, how many people know how to fill out envelopes anymore? And it was like shockingly embarrassing. Like where you put the difference. Like, how many of you have ever touched a stamp? Not everybody. You don't need to anymore. Plus, the post office will probably lose it. So it's a crapshoot. But in any case, we evolve how we want to represent stuff. Now, in programming, well, in technology, let's say, how many of you have seen something called XML? Just seen those letters next to each other. Okay, do we know what that is? What is XML? Okay, file type of some sort. Anybody have any more? Anybody know what it stands for? Kind of unimportant, but a history lesson. It's extensible markup language. Okay, so he mentioned, is it used with HTML? This becomes a chicken or the egg question. Which came first, HTML or XML? I'll give you a hint. It was HTML. XML was built because we looked at HTML, which is a tag-based language. So let me get another slide going here. So for instance, XML. Let's say we want to store a person in terms of first name, last name, and age. Let's say we wanted to keep track of those three pieces of information. All right. Now, if I say, okay, you get to put this into a string. You get one string, and I want you to be able to say something like Mike Littman, and how old do I want to be? 25. Well, that way I can rent a car. Don't they charge, if you're under 25, don't they charge like an arm and a leg to rent a car? Or can you just not even do it? I know the younger you are, they charge you way more for the insurance or whatever for it. Okay, so in any case, let's say I want to represent this data in a string. Well, one thing I can do is I can say, okay, I'll just put it in a string and I'll separate each data point by a space. And then I can split that up on spaces, or I could say, well, let's do this as comma separated values. Now, why might you choose comma separated values instead of spaces?
Like if you make a and accidentally put a space after the L in Littman, then you'll end up with 4 different parameters rather than.
But what if you don't make a typo?
Or if the values have spaces.
Yeah. If you want to be able to transmit a space as part of your value, you can't use that as your separator. But what if I want to send a comma as one of my values? Kind of the same problem. It's just a moving target, right? Yeah. You could do, or, so what we're doing here is we're kind of going back in time and looking at when things were proprietary. Okay, when each company was making software, had their own little internal proprietary format for stuff. So this guy right here says that, okay, I can't have spaces in my actual pieces of data because I'm splitting on spaces. This guy right here says, okay, I can't have commas in my actual data because I'm using commas as my thing to split this on. If I'm trying to hold everything in a single cut. Well, what do you mean? Why does it matter? Oh, so if you know, okay, the data I'm representing never has spaces. Like we might say that in this case, right? First names probably don't have spaces in it. Last names probably don't have spaces in it. Ages probably don't have spaces in them. So since we know the nature of our data, then we can say it's safe to use spaces to separate that particular data. Okay, fine. So now your separator was driven by the nature of your data. but now not everybody is sending the same kind of data, right? So let's assume you did want to have spaces in your data. No problem. So we could say, okay, well, I want to be able to send my whole name, not just first and last name. So I want a space in there, but I also want my age. So now you can say, well, obviously a space is not a acceptable separator because this breaks it, but I can make commas as the separator. Now I've just disqualified commas from my data. Not the end of the world if you know your data is not going to have commas in it. Okay. But this is kind of this moving target, right? Every company would use a different separator type thing when it was trying to package up information into some sort of format that you can easily hand it to like a function. Like you hand a function this string and say, here, this has all 30 pieces of information you might need housed inside the string. Once you get the string, you got to slice it up into its individual pieces based on how you separated it. And because each company knows the nature of what their data looks like, they get to choose what that separator is. So if you had 50 companies writing software, you may have had 20 different separators, because depending on the nature of their data. Sometimes they would get a little bit crazy with it. And you might do something like this. You know, you sit there and say, okay, well, what is likely never to ever be something that I actually want to put inside my data? Maybe something like that. The chances of my data holding a less than sign followed by 3 equal signs followed by a greater than sign seems really, really low, right? Okay, like we probably could have made that the standard and very rarely ever run into issues. Okay, but you kind of get where we're going with this. Everybody had a different approach. It was a proprietary approach. XML was a tool that came out to add metadata to your data to describe your data. So if we were doing this in XML, what our code would look like, let me actually do this just so it's not in bullet point format. So maybe we do something like F name, Mike. And before this, we would say person. L name. Age. So something like that. This would be what XML would look like, where now you can look at this thing and even if you've never seen this before, you can look through here and say, okay, Mike is probably the first name. Lippman is probably the last name. Age is the 25 that's there. Okay. We've marked up the data by surrounding it with tags that describe it, kind of like variables, right? All right. So XML was kind of born. Now, HTML looks a lot like this. So HTML is the representation language that your web browsers know. Chrome, Safari, Firefox, whatever you use. So if you look at HTML, it has a collection of tags that represent stuff you would find inside of web pages. Anchor tags, text things for making, you know, how big of a header it is, all sorts of stuff, centering things. So it's a limited list of tags, but it's all the stuff that you can describe to your web browser for how you want something to look. Well, somebody said, hey, why don't we just take that concept and we can now just apply this whole tag type language to describing our data. So now we have a consistent way that everybody can use for sending their data from place to place. And we don't have to worry about the proprietary nature of what are we splitting on, stuff like that. All right. Now, what would you say? Oh, go ahead.
So XML is basically using a tag language to describe and send data.
Yep, that's it. All right. Now, if everybody can look at this and say, yeah, that makes sense, right? If I asked you, if I just put this in front of you for the very first time, never even talked to you about XML, every one of you could look at this and say, okay, it looks like there's 3 pieces of information in there. As human beings, we can pull that information out and say, okay, this is a first name, a last name, and an age. What would you say is the weakness of this?
Probably copying and pasting it, or if you had to make another person, you have to redo the same thing.
Okay.
It's not like a function thing to.
Well, I mean, we could write a function that generates this. I mean, can't we write a function that takes in a first name, a last name, and an age and spits out this?
XML?
Well, we could write it in Python. I could write a function in Python that takes in 3 parameters, a first name, a last name, and an age. And then I can just build the string that looks like this using concatenation, right? I can just make that string. Poof, XML. Now, if I want to pass in a different first name, a last name, and an age, I can do that. Same function. It'll make me the XML object out of that. No problem. There is just as much formatting data here as there is real data. In fact, probably more. So when we look at this, a majority of what we're seeing here is metadata, stuff that's describing our actual data, not the data itself. So yes, it functionally does a good job. And since now we have plenty of memory and our internet connections are really, really fast, relatively speaking, blah, blah, blah. It's not that big of a deal if we have extra text because text transmits really, really quickly. But we still can say, you know what? If I have 3 pieces of information, I want to minimize the amount of extra stuff that I need for to represent that that data. But we can certainly say that this guy feels like an upgrade to proprietary decisions. That sound fair? Okay. So we used XML for a while. In fact, so I call these data representation languages because it's not a programming language. That doesn't mean it's weak. Programming languages all have what? 100% of programming languages have facilities for remembering things, asking questions, repetition. This doesn't. HTML doesn't. HTML is not a programming language. It's a data representation language. Now, how many of you have ever done any web development before? Okay. So doing web development, do you only use HTML or do you have some other things you use? Why JavaScript? Because HTML can't remember stuff, ask questions, or repetition. We have to create our web pages with an additional tool like JavaScript, which is a programming language, whenever we do need to remember stuff or ask questions or do repetition. Make sense? Because HTML didn't do the entire job for us. In the early days, maybe most web pages were just purely visual, but very quickly web pages were much more dynamic, where they were responding to, like, I click a button, I want something to happen. Refresh sports score, log into websites, whatever it is, so dealing with these web forms and stuff, you need something more than just HTML. That's why web browsers support other things. And now, now you have like CSS. Anybody know what CSS stands for? Yep, cascading style sheets. And what problem does CSS solve? Good. Why do you need to store it as CSS? Can't you just make it look the way you want it to look? Yeah. So imagine you're a designer before a web designer before CSS was a thing, and you had a website with 20 pages on it, and your color scheme uses a red background, and you decide you want it to now be a blue background. You got to go and change that on 20 pages, as opposed to you change it in one place, your CSS file, and then all the pages reference your CSS file, so they all instantly change to the blue background. It's solved the problem. It made it more convenient to consistently create your website for a look and feel. And when you change the look, was immediately seen throughout your entire application. Okay, so for a long time when we had our, when we needed to transmit information, whether sending information to someone or receiving information, whether we were a function, whether we were talking to another program, doesn't matter. When we needed to exchange information between two things, we might put it in the format of XML, and because it has this tag-based thing, every opening tag person has a corresponding closing tag, /person. So F name /F name, L name /L name, age /age. That is the format of XML. It's a tag-based language, and HTML follows this. Now, if you're in a web browser, and up top, you find in one of the menus, any of you ever seen something up there that says XHTML? And it's usually turned off by default. So you can put your web browser into XHTML mode. What do you think that means?
Extended HTML.
Okay, but so if you tell your web browser to follow XHTML, what are you really telling it to do? You're telling it to adhere to the exact rules of HTML built with XML, which means you have to have a closing tag for every one of your opening tags. It's the law. Okay, so XML says if you're going to write something that's going to parse this data, when we find an opening tag, we must find a corresponding closing tag. Otherwise, we can't write a program that generically processes a formatted document like that. Go ahead. Much looser. So you got to think about where this all came from. So in the early days of the web, people would write HTML by hand, and the browsers would, you would write it and you would keep manipulating it until it looked the way you wanted it to look in the browser. So early web browsers were like Mosaic was an early one, Netscape, Microsoft Explorer came out a little bit after that. So as a web designer, when you're writing your web pages, you actually have to test it in multiple browsers to make sure it looks the way you want it to look in every browser. Because over the years, what happened is browsers had to loosen their rules up to make them deal with less than perfect HTML, but still get the gist. Because of some early tools. So again, it's always Microsoft's fault, right? Microsoft had a product years ago called Front Page. And Front Page let you basically design your web page like you were using Microsoft Word. You just make this pretty web page, you save it, it saves it as HTML, but it saves it as HTML generated by Front Page, which didn't follow all the rules of HTML, but was always going to be compatible with Internet Explorer, Microsoft's browser. So all the other browsers then had to make theirs compatible with Front Page, because lots and lots of people now were able to create their own websites using Front Page. They might not have been techie and able to, even though XML doesn't seem like it's that difficult, it starts becoming intimidating because it looks code-like or whatever. So everybody was already used to using word processors and stuff. It's like, oh, we're going to use Front Page, make our websites perfect. So you had a zillion people doing that. Well, all the web browsers want to make sure all those people's websites look fine in there, so they loosen all the rules. So a lot of websites that are out there, especially older ones, are going to have less than perfectly formatted HTML. Yet they can get away with it because the browsers have all these exceptions put into it. And you can experience this by putting your browser into XHTML mode, which says you must follow the rules of HTML in order to solve this, in order to display. You'll all of a sudden start going to a bunch of websites, especially older ones, that are broken. They won't look right because they had syntax errors in their HTML. Make some sense? This is just the evolution of technology, because early on we had primitive tools and we made little adjustments just to make something work. We duct taped it, right? Microsoft said, oh, well, somewhere in there, there might have been a little, I guess, company secrets or whatever, where Microsoft said, well, we're going to make sure front page puts stuff out that is in just an incredibly inconvenient format. And we're just going to make sure it works in our browser. Look like crap in everybody else's browser. That way everybody has to use Internet Explorer, which was Microsoft's thing. What's it called now? Edge? What's it called this week? There was another thing somewhere in the middle. I think it had a name. But regardless, so we've had this very loose thing with the web for a long time. And even today, by default, your browsers have XHTML mode disabled because too many sites would be broken, because there's a lot of stuff that's been out there for years and years and years, or people who use like these third-party tools to make pretty websites that they couldn't have done on their own, but it generates it for them, and they're at the mercy of the HTML code that they produced. And sometimes it's not perfect HTML. So it's kind of a thing. As computer programmers, we care less about this because we're not really looking at it from, effectively web browsers and HTML gave us the inspiration for, here's a way of representing data. XML said, hey, let's just say you have an opening tag, you have a closing tag, and now you can represent any data you want. Largely, let's say, using XML. And now, because it follows a strict standard, we could write a computer program that walks through this and extracts the pieces of information. And we in this classroom already know how to do it. It would be tedious, but we've been working on string manipulation problems. If you read this thing in as a string, you could look for an opening less than sign. Keep walking till you hit the greater than sign. Now you know you're at the end of that tag, right? So from that point forward, the next characters you're collecting are the value until you finally hit a less than sign followed by a slash. That's the end of that value. Make some sense? So every one of you in here has the knowledge now. It might take you some time, might be difficult, but you can write an XML parser that can take any XML and pull the information out of it. Okay, but we're going to say a weakness of XML is just, it's verbose. Lots of fluff when there could be less. Anybody know what kind of replace XML? What do we largely use today instead of XML? There was a period of time where most online APIs, like if you were talking to, like for instance, if you're talking to OpenAI API, so if you want to use ChatGPT in your programs, you can write your program in such a way that it reaches out to ChatGPT with a prompt and any sort of extra settings that you want to have in there, and it then sends you the result back. Okay, we write that request up in a format similar to XML because it has to say more than just the prompt. It's like, give me the prompt. There's a couple of different kind of settings you can say for how long you want it to think and this kind of stuff. Whatever it is, there's several parameters that go into this, almost like making a remote function call. So you need to package up your function call into some sort of format that you can send over the internet, and on the other side, it receives it, unpacks it, and then does your bidding. And then in the end, it packs up the answer, ships it back out. It's like the US mail, except instead of using an envelope, we're using XML, or modernly, anybody knows the replacement for XML, basically? Something called JSON. How many of you have seen those four letters next to each other at some point? JSON. Okay, do we know what it stands for? JavaScript object notation. This is how object-oriented programming was added to the JSON programming language using this format. So for example, Let me do it like I did on the other screen. To represent that same data, do what I say. Here's that same data in JSON. Now, if I put that in front of all of you and you had never heard of JSON, never programmed before, could a human being look at this and pretty much extract the information and its meaning from this? Is this just as good as XML in terms, actually, it's probably better, right? Why does this feel better than XML? Yeah, less extra crap, right? We don't have all this extra taggy looking stuff in there that, hey, it got the job done, but it created a whole lot of fluff, right? Go ahead.
HTML, there's like much information, it's better to use this.
Use this for what?
For storing data, like.
Yeah.
How to store a roster.
Yeah.
Store.
JSON is kind of what you might use to locally store some information if you aren't quite needing a full-fledged database, something like that. Because it is going to use the local file system, which is slower, but it's fast enough that a human being is not going to notice in a single user application. But yeah, so JSON stands for JavaScript Object Notation, and it is the format that we use in JavaScript for representing objects. Now, it's also the format for something in Python. What does this look like in Python? For those of you who've used Python before, what does this look like? A dictionary. So in Python, I think have you messed with dictionaries yet in the so remember, we're talking about data representation stuff here. So Python collections. So we have different ways we can store things in Python. Well, we've talked about a variable. So a variable lets us hold a single value. Hold a single value. Then we have a string. Hold a collection of characters. Then we have a list. What's a list? What differentiates a list from a string?
Variables.
Things other than just characters. I can have a list of numbers. I can have a list of Booleans. So it expands the concept of a string. A string is really how we store words and stuff, because that's, human beings, we want stuff in, sentences and that kind of stuff. So if we're going to store stuff in words, now we have, even today, as we're talking about, hey, what are some different ways we can represent information? We've gone back and looked at this and said, well, I can technically hold my first name, my last name, and my age all inside of a single string, right? And get the job done if needed. But what if we were going to put this in a list? Could I have a list that holds Is that a legal list? Why?
Values.
Uh, Is that a legal list? 268? All right, so this guy is a collection of numbers. Where this guy up here is a collection of a string, and a number.
Python is legal.
Yep.
Oh.
Most languages it's legal. Part of, well, as long as you've done it through inheritance, we'll talk about that when we get to objects. But a list can hold a collection of any kind of value. So a list holds a collection of any value types we want. And we'll be able to explain how that works because everything comes back to this idea of an object. So we'll explain that in the future soon enough. But for right now, let's just give the definition of a list in Python is a collection of anything we want, including mix and matching. We can do that. All right. So I could store my pieces of information inside of a list like that. Now, which is better? Storing it in a list like this or storing it in a string like this? Why?
Easier to parse out different values.
Okay. So we might say from a human being's perspective, we can look at either of those and pull out our information because we're really smart, right? We don't need to think about the code it takes to parse this stuff apart. Okay. But as he just said, well, if I'm going to be dealing with strings here, I'm going to have to split on the space, which is actually going to give me a list. And then from that list, I can pull out the thing at bucket 0, which was Mike, the thing at bucket 1, which was Lippman, and so on and so forth. As opposed to if it was already stored in a list, we just use Python's syntax for working with lists to extract our pieces of information. But what we don't have here is we don't have this information labeled. We have to kind of remember that bucket 0 of this list holds our person's first name. Bucket 1 of this list holds our person's last name. Bucket 2 holds our person's age. Those are just things that these guys do, and we have to remember it. Not the end of the world when we're dealing with 3 pieces of information, but what if you're dealing with 300 pieces of information? Ever got one of those spreadsheets? They give it to you in a CSV file. You ever opened a .csv file? When you double click on that, what does it open in? Excel. So anybody know what .csv stands for? Like if you see at the end of a file .doc, what kind of file is that? What if you see a .docx? docx. Well, when you say document, if you double clicked on a .doc file, what would it open in? What program would it open in? If I had a file named resume.doc and I double clicked on it, what program would open it?
LibreOffice.
Some word processor that's compatible with Microsoft Word, right? Okay, so he's using an open source one, which is fine. All right. What if it said resume.docx? Would that also open it up in a program that's compatible with Microsoft Word files? What's the difference between a .doc file and a .docx file?
DocX files are good.
Well, they're open. Basically, Microsoft Word has been the word processor standard for decades. Every word processor knows how to open a Word file is what it comes down to. But they used to not be able to. Why do you think? A .doc file uses Microsoft's old proprietary data representation format for their Word documents. Because a Word document is kind of like a web page, isn't it? Like you're storing formatting, bolds and sizes of things and all that, and colors. So we have to have some way of telling Microsoft Word the information it needs in order to process this information that gets put in front of it. So then docx comes out. You think, how is docx better than .doc? Okay. What do you think the X stands for?
Edit.
XML. docx was Microsoft's redoing of their format to use an XML based format for their documents. So inside they picked their own tags they wanted to have and stuff. But if you were to crack open a docx file, and they might encrypt it or something, but if you were to get to the actual data that's stored in there, it will be XML looking stuff. It'll look like this kind of thing. That's what's in a docx file. All right. So it's really less proprietary, even though we have all these word processors today that can open up a doc file because they've kind of reverse engineered it, right? They didn't have Microsoft's, Microsoft didn't like open source their formatting. That was how they were protecting their intellectual property. But enough people opened it up, saw kind of what the various weird tag, are they separating it by commas, spaces, the weird symbols like this, whatever it is, and they said, oh, we'll just write a thing that parses that. So they were able to reverse engineer it, but still they were operating off a proprietary format. Now it's an XML format. Okay, so storing stuff in lists gives us the ability to hold various types of information and gives us the ability to not have to parse it, but to immediately access the various buckets of that guy to get at the information. But it doesn't contain with it what's commonly called in technology metadata. Metadata is data that describes other data. That's what metadata is. Extra data. Extra data. All right. Now, I know we've heard this word in class before called an array. It doesn't really exist in Python. Python kind of skips past it right into lists. But her answer earlier was really the right answer for arrays. So an array is a collection of like types. Every element in the array has to be of the same type, but they don't all have to be chars. We can have an array of ints, an array of strings, an array of chars, an array of booleans, whatever it is. So holds a collection of like types. Can't store more than one type. And that's only sort of kind of because you can accomplish it using inheritance with object-oriented programming. And we'll talk about that when we get to it. But for right now, just understanding that arrays, which is what you will likely usually be using in any C-based language, the first collection type you run into would be an array where you're like holding a collection of numbers or a collection of strings, something like that. All right. What about a dictionary? Which we've seen is actually JSON format. But what's unique about a dictionary versus a list? Holds the metadata. So we could say same as a list, but holds the metadata to describe what each value is. This last part's kind of an important piece here when you're working with Python, but really most languages that have things like dictionaries, is they do not guarantee the order in which they're storing the things. So you can't go through and say, give me the first value, give me the second value, give me the third value. You would go and say, give me the value associated with first name. Give me the value associated with last name. Give me the value associated with age. Make some sense? Okay. So it's not our purview to know how it's representing that under the hood or how it's storing that. So you can't just iterate through it from beginning to end based on bucket number. You can iterate through the keys. So a dictionary has keys and values where the keys are the metadata and the values are the actual data. This is JSON. JSON looks like Python dictionaries. It's all the same thing. All right. So we have different ways of holding stuff in Python. So now when we talk about our fractions, should just move this guy down here so it's kind of in the right order. All right, so do we understand this idea that as a programmer, we have all sorts of choices how we want to represent data based on the complexity of the data we have, right? There isn't just like a right answer. You know, we can go MacGyver style and put all sorts of weird separators if we want to be proprietary, or chances are we're just going to use a dictionary to do something for a lot of cases if you have, you know, larger pieces of data, or you invent your own objects and just put it in there and pass around the objects. We're going to be looking at that soon enough. All right, so if we're representing the fraction 1/2, we could represent it as two variables, numerator and denominator, right? That's the most straightforward. You know, you could do that after the first week of class conceptually. I know programming is still an intimidating thing for many of you, but conceptually, we know what variables are. They're name value pairs. I can hold numerator inside of that guy and denominator inside of another guy. We have two separate variables to represent it. Or, so we could have something like numerator equals 1, denominator equals 2, and we could just say, okay, that those two variables together represents the fraction 1/2. Fair enough? All right, we can also say, well, I'm going to represent it as a string separated by a slash. Everything before the slash is the numerator, everything after the slash is the denominator. We wrote that in class last time, a way to pass into a numerator and denominator into a function, and then it just glued everything together into a string. I think we have it. Oh, we didn't actually create them here. I'll create it real quick. So we're going to say def make string fraction. This guy will take in a numerator and a denominator. And we will return a formatted string that is numerator, followed by a slash, followed by a denominator. So now I can say make string fraction 1, 2, and it will give me my 1/2. So it constructed, given the two pieces of information, it made me my special kind of fraction, right? Well, what could we have also done? Could have also said, well, we want a def make list fraction, taking in a numerator and a denominator. And what are we going to do here? We're going to return a list containing numerator and denominator. I'll pass it my 1 and 2 again, and we see we have the list representation of a fraction. Just these guys are, we would call these two functions here constructors. They make fractions in the format that we want it. We're going to evolve this idea of a constructor pretty soon when we write our own objects. We're going to be writing a fraction object probably next class. But this idea of a constructor is the thing that initially builds your thing. All right, so I'm giving it all the information it needs. It's going to produce my outcome, my output. All right, well, we can also say def make dictionary fraction, pass in a numerator and a denominator. And we can go ahead and say, call this guy the fraction. And I'm going to do it as individual pieces. So I'll start it off as the empty dictionary. And then I'm going to say the fraction dot, sorry, the fraction at numerator is equal to numerator. The fraction denominator is equal to denominator. And then I'm going to return the fraction. We could have built it the same way as I did in the previous ones. I just want to show it this way. I'll explain why here in a second. Then I'll go ahead and say I want to print make dictionary fraction 1 and 2. And we see what it built for me here is something that looks like that. That's JSON, right? It's a bunch of name value pairs separated by commas, but it has the metadata in here, numerator and denominator. If I were to say F4 is equal to this guy, I can then say print out F4 at bucket numerator, not at bucket 0 or bucket 1. Give me the value at bucket numerator, however you've stored that, and we'll get the 1 out of there. If instead of numerator, I say denominator, I'll get the 2 out of there. All right. So now I have something that has more metadata, though it's kind of self-descriptive. I don't need to remember which position in the list I put a certain value. I can just say, give me the numerator or give me the denominator. Make sense? Well, so let's go back here. So we can represent it as a string. We can represent it as a list. We can represent it as a, here, I'm actually going to steal this guy real quick so I don't have to type as much. We can represent it like that. Okay. Now, what's the weakness of this guy? All the data's there, right? But all this does is store data. If we're thinking about working with objects, and you know, when you take your smartphone, we know this guy has a whole bunch of different abilities, right? Now, you have stuff stored in here that is part of the data it's remembering, right? So that's part of it, but also we rely on this for having different functions. There might be a function called volume up, a function called volume down, a function called power on or screen on or whatever, okay? None of that is represented in a dictionary. Dictionaries only represent the data, not the abilities. So that's the piece that is kind of missing. That's if we think about the evolution of programming languages and we're just kind of stumbling along like, okay, variables until, well, I can't just make 5,000 variables for this. This is inconvenient. Well, let's store it in a string. Okay, well, what do I delimit this by? Store it in a list. Okay, well, now I got to have a separate document that says what each bucket of the list has in it. Well, now I'll put it in a dictionary. It's like, okay, now it's kind of self-documenting, but hey, it's all it can do is hold data. Human beings were never happy, right? It never does enough. So we could say the problem. They can only hold values, not abilities. Now, sometimes that's enough. Now, are dictionaries always better than lists? What if I just want to hold a collection of 50 random numbers? That doesn't even make sense in a dictionary, right? What am I going to call it? Number 1, number 2, number 3, number 4? Might as well just store it in a list and have bucket 0, bucket 1, bucket 2, bucket 3. It's ultimately about using the right tool for the job. That's why all these things live in these languages. All right, so we'll pause there. I do encourage everybody to work on that second sheet of functions that was sent, not to turn it in for practice. This is like drill practice for the midterm. The midterm will have a lot of string manipulation type stuff on it. We'll talk about when the midterm is. It'll be around week 8, but what I'm telling you is that getting good at those kind of functions will make the midterm feel easy. All right? I'll see you.
Like it's gonna be pen and paper.
I hope not, because I don't want to grade that, but probably not. But I reserve the right to change my mind.